Welcome to The Explainer. I am so glad you're joining us today because we are diving into something absolutely wild. We're taking a look at Google VEO 3. And we're going to go on a pretty fascinating trip today, starting all the way up at the raw, immense technical power of this generative AI model and zooming all the way down to its actual, real-world impact on teenagers sitting in a high school biology class. It's this incredible story of how cutting-edge code actually translates into human learning. Here's a quick look at our roadmap for today. First, we'll officially meet Google VEO 3. Second, we'll peek under the technical hood. Third, we'll talk about building with the API. Fourth, we'll see VEO in the classroom. And finally, we'll wrap up with safety, ethics, and risks. Let's get right into it.
All right, part one, meet Google VEO 3. Let's just set the stage and look at exactly what we are dealing with here.
The sheer leap in capability we're seeing is honestly staggering. VEO 3 isn't just generating your standard moving pictures, it is pumping out stunning 4K video. It gives you configurable aspect ratios, meaning you can spin up a sweeping cinematic 16:9 landscape or a perfectly formatted 9:16 vertical video for your phone. But the absolute game changer here? The native audio integration. You know how older models made you dub the sound in post? Well, VEO 3 generates the spoken dialogue, the background environmental sounds, and the visuals all at the exact same time. When you combine that natively synced audio with advanced real-world physics, like the super-accurate interplay of light, shadows, and fluid dynamics, you are looking at an incredibly powerful cinematic engine.
Moving on to part two, under the technical hood. We know what it looks like, but how does it actually pull this off? Let's talk about the science. The huge breakthrough here is something called latent diffusion. See, instead of the AI trying to learn from giant, raw pixel files or heavy audio waveforms, which would completely fry the compute, the data is first compressed by autoencoders into what we call a latent space. The model then applies this denoising process jointly to both the audio latents and the spatiotemporal video latents. Basically, it just iteratively strips away Gaussian noise until it reveals the final, pristine video. This specific architecture is exactly why VEO 3 is so efficient and so perfectly synchronized. If you trace the journey from left to right here, you can see how a text prompt and maybe an optional reference image get fed into their respective encoders, like the UL2 encoder for text. These turn into embedded prompts, and they meet the noisy, compressed latent representations right in the center. That's where the latent diffusion model goes to work, cleaning up all that noise based entirely on your prompt before passing it out through the decoder. What pops out on the far right? A flawless 1080p or 4K video with fully synchronized audio. It's literally translating human imagination into math and then rendering that math right back into reality. Just wild.
Okay, part three, building with the API. So we've seen the dense, heavy machine learning side of things, but how do developers actually get their hands on this tech?
For the developer crowd, you access the VEO 3 API through Google Cloud's Vertex AI. Now, since kicking out AI video requires massive computing power, you definitely can't just expect an instant real-time response. To handle that load, the system uses a really solid 4-step asynchronous workflow. First up, prompt validation. This ensures your prompt doesn't violate safety policies, which saves you from wasting time and money on a failed render. Second, you trigger the asynchronous generation. Third, rather than totally freezing your app while it thinks, you use polling or webhooks to just wait for a completion signal. And fourth, the final video drops securely into your Google Cloud storage bucket. It's totally built for enterprise-scale automation.
But here's the catch. Developers have to be incredibly strategic because access is definitely not unlimited. If you're on the default project tier, you only get 5 requests per minute and a maximum of 3 concurrent operations. If you built a viral app on that, you'd hit a brick wall immediately. So devs have to carefully manage their operations, implement caching for identical prompts, and eventually apply for elevated or custom enterprise quotas as they grow.
And yeah, we absolutely have to talk about the cost. The VEO 3 API bills you per second of video generated. High-quality 1080p generation runs around 50 cents per second. So to put that abstract pricing into some tangible perspective, if you wanted to generate a batch of just 100 8-second clips at 1080p, that's going to run you a flat $400. It is a premium product for sure, so developers have to make sure their business model can actually support those generation costs.
Because of that premium price tag and the strict access, developers are constantly weighing alternatives, like the Cdance API, for instance. While VEO 3 is the undisputed premium choice, you get the highest quality, but you deal with a strict allow list and per-second billing, Cdance acts as a highly capable alternative. It gives you excellent quality, totally open access and lower costs that even include free commercial rights out of the box. So for devs, choosing between the two really comes down to whether that absolute top-tier cinematic quality is worth the premium pricing and the extra hurdles.
Which brings us to part 4, VEO in the classroom. We know what the API does, we know what it costs, but what actually happens when you hand this powerful AI over to a teacher standing in front of 15-year-old students? This leads us to a really fascinating qualitative case study published in the Sinop University Journal of Social Sciences. Researchers actually went into a public high school in Ankara, Turkey, to observe a 10th grade biology classroom. The teacher there used VEO 3 to build an instructional unit focused on a super complex socio-scientific issue, climate change and biodiversity. The teacher fired up VEO 3's flow interface and typed in this exact prompt. Look at how specific and intentional this is. They didn't just casually ask for a video about global warming. No, they directed the AI to weave a targeted scientific story, an educational narrative using very specific biological markers like coral bleaching and polar habitat loss. The result? A seamless 2.5-minute narrated video that perfectly visualized these abstract ecosystem disruptions, and the findings from the researchers were honestly remarkable. VEO 3 successfully acted as a real pedagogical partner by showing the progressive bleaching of coral reefs or a polar bear struggling across fragmented ice, complete with a calm scientific voiceover and the sound of crashing ocean waves. The video didn't just boost the students' conceptual understanding, it actually dramatically increased their emotional empathy toward environmental challenges. But the teacher was smart. They totally understood the danger of letting teenagers just passively consume hyper-realistic AI video as absolute truth. To counter that, they rolled out a 3-step critical media literacy framework. Right after the video, they hit the students with 3 questions. What is actually being shown here? How do we know this is scientifically accurate and not just an AI hallucination? And crucially, what might be missing or oversimplified in this generated story? This ensured the kids weren't just learning biology, they were actively interrogating AI media and building critical digital literacy.
Finally, part 5. Safety, ethics, and risks. Because look, when anyone can spin up hyper-realistic video on demand, the ethical weight is massive. Let's look at the guardrails keeping this thing in check.
Well, before VEO 3 ever saw the light of day, Google's independent red teaming groups rigorously attacked it across several critical risk domains. These adversarial testers literally tried to break the model to expose vulnerabilities. They focused heavily on stopping the generation of disinformation and deepfakes, non-consensual intimate imagery, child sexual abuse material, and CBR&E, which stands for chemical, biological, radiological, nuclear, and explosive materials.
What's super interesting is how Google addressed that last one, the CBR&E risk. When testers tried to force it to generate tutorials for biological or nuclear weapons, they found something incredibly reassuring. VEO 3 intentionally has a terrible understanding of nuclear physics and sequential detonations. It consistently fails to accurately render blast geometry or missile flight dynamics. So in this specific scenario, the AI's lack of capability is actually a feature, not a bug. It intentionally lacks the physical understanding required to meaningfully help a bad actor generate a technical weapons tutorial.
Now, beyond those pre-training limitations, you also have post-training mitigations. The big one here is SynthID. This is Google's Invisible Watermarking system, and it is baked directly into the pixels and the audio of VEO 3's output. Even if someone maliciously trims the video, compresses it for social media, or messes with the colors, SynthID allows detection tools to instantly flag the media as AI-generated. That is absolutely crucial for maintaining transparency and fighting the spread of deepfakes globally. Which brings us to the end of our explainer today, and leaves us with a pretty vital question to ponder. We've seen how VEO 3 can decode the latent space to build entire worlds out of thin air, how it powers developer platforms through robust APIs, and how it can profoundly move high school students learning about climate change. With AI now serving as both an educational partner and this immensely powerful cinematic engine, how will we as a society choose to direct the next frame? The tools are right here in our hands, but the responsibility? That's entirely on us. Thanks so much for learning with me today.